Hey guys, in this video we're going to take a look at how to solve this problem. That's right, my Audio-Technica System 10 receiver mount here is less than useful. Basically allows the receiver to slide out way too easily, causing all manner of possible damage. We'll also look at when we rebuild this mount to make the profile slightly shorter. Okay, so stay tuned. RJ here, back with another video. So in this video we're going to be taking a look at my Audio-Technica System 10 wireless mic system, specifically the receiver. Now the receiver comes with this bracket, this mounting bracket that is extremely flexible and unfortunately does not hold the receiver very well. Matter of fact, it's downright dangerous. It slips right out. So in this episode, we're going to take a look at how to design a new bracket / mount for the receiver in Fusion 360. So you ready? Let's go ahead and get to it. Okay guys, we're not going to go ahead and rebuild this from scratch. It's a pretty straightforward design. So I'll just go over my design timeline, make this pretty quick. So starting at the sketch level, and by the way, this is what the final product looks like, if you will. So let's go ahead and start with the base sketch. And I always try to base my designs off a sketch and dimension it as well as possible. Now there's probably a gazillion ways to do this, and I'm sure this is probably the most inefficient way. I do know that I could have, kind of did this in half and mirrored it, but it's such a simple design, I figured I would just use the line tool, and that's exactly what I did. Just kind of measured with my caliper the existing mount for the receiver, and then just basically lined off, did a rough line off, and then using the sketch fillet tool, created my fillets along the edge. Now I did create a simple construction line just to give me an eye of where my two little nipples were going to go or end up, the points where they're going to end up. These areas kind of slide into the contouring of the receiver. So from here, all I did was, we'll go ahead and reduce this timeline down so it's picture by picture. So I extruded that up 19 millimeters, and basically this 19 millimeters that is extruded up is the base area or the contouring area of the receiver. So from there I created another sketch right on the top of that last extrusion, and just simply 45'd it right here on both sides. So from there, extruded it up, 61 millimeters, and basically this creates the majority of the mount sled, the area where the receiver will slide into. From there, created another sketch off of the back here of this back plane of the sled. Simple rectangle box, just dimensioned off. I just threw out a number, kind of guessed at it, kind of centered it up. And then from there, extruded that up to a big block rectangle. Did some chamfering work on the edges here, kind of softened it up a bit. Did a little chamfering work here. These are fillets and chamfer. And then from there, I created another sketch on top of this newly created area, and this would form our hole for the mount, 6.5 millimeters. So from there, I did a subtractive extrude. We removed the material. I went down 14 millimeters, basically pretty much on the edge there, as you can see. And the reason why I did that was so I could have some options with screw lengths. So from there, let's go ahead and rearrange that.
From there, using the thread tool, boy, that just makes life so much easier, especially if you have a standard thread. In this case, I did just a simple 6mm right-hand thread. Created that. It's a beautiful, beautiful thread. From there, created another sketch right off of this top plane, and this sketch will serve as a lip, creating a lip. And let's go ahead and show you that extruded out, what that looks like. So basically, when the receiver slides in, locks in back here, the face of it will drop down into this area. And this lip, the face of the receiver will be behind this lip. So even if the camera takes a hit or gets jarred, the receiver isn't going to slide out. This lip is going to stop it. So even though that this contouring, I tweaked it pretty good, so it's pretty tight along the edge of the back edge of the receiver. I just wanted some extra protection here, just to make sure. So let's go ahead and rearrange this. So from here, I just did some simple fillet work at the top, along the edge there. Some fillet work along the bottom here, just so when the receiver slides in, this isn't a sharp edge, it's kind of a softened edge, so it won't kind of chip. And then lastly, a bit of a chamfer along this edge, just to give this lip just a little bit of strength, a little extra strength here, from this plane to this plane. And it makes it just slightly easier to print because it's, it can work off that edge. And I wanted to design this with, utilizing no supports. And that's primarily what I do in all of my designing, even if it means that I got to cut a model in half and glue it or make some type of connection. I just really hate printing with supports. So as you know, or you may know, from there, once you've got your model completed in Fusion 360, you can just click on the body. In this case, I have a single body. So right-click on it, save as STL, and you have a choice to, you can send it to a file or to an application. In this case, I send it to Simplify 3D, which we'll go ahead and do now. So here it is, dropped in, and as you can see, it unfortunately uses a random name. So that's really the only part I don't like. I wish it would transfer it with the name it was given. But anyway, obviously we do not want to print like that. So the easiest way to orient your model is to use the keyboard combination Control L and click on the surface that you want to meet to the bed. So in this case, I want this edge to meet the bed. And there you go, instantly to the bed. Now, if you want to orient it, the quick way to do that is just use Control R, and that'll orient the models in the center of your bed. So we're going to print this without any supports, and there's nothing special about the print process. I'll go over it real quick. It's just a standard FlashForge Creator Pro ABS slicer settings. And here they are for me. Layer on this is going to be a medium, so at this 0.2 with a 443. That's 4 top solid layers, 4 bottom, and 3 shells. Probably well, not probably, it's overkill for this model, but I don't know, I like to go a little over and a little less. Additions, no additions, infill as you saw, it's just standard infill. Support material, no support. So the heated bed is 2-stage, so starts out at 100, and then at the 10th layer goes to 90. That seems to work pretty good for me. The extruder temp for, in this case, Hatchbox, is 230 degrees Celsius. Cooling, I start at 5, the 5th layer. Now with FlashForge, at least with the Creator Pro, it doesn't matter what you put in here as far as the percentage, your speed. It's always 100. So even if you put the 50 there, it's going to be 100. Just a heads up there. Nothing special with the code, scripts, or anything else. It's all just standard stuff. So yeah, let's go ahead and slice this. We'll do it in real time and see how fast it is. As you can see, Simplify 3D slices extraordinarily fast. Now, granted, this is not a detailed model by any means, but it's fast. So anyway, so this would be like a final print. It would be a full body print. So you can see there's no surprises here, and I like to check just to make sure I don't have any surprises. Yeah, that is thin, isn't it? Yeah, it'll be fine, but yeah, that's a little thin on that. I could have probably, instead of going to 14 millimeters, probably just created 12 millimeter depth hole, but it was fine. So, but one of the tricks I used in designing, so I didn't waste filament, was to orient this. So my biggest problem with it was this profile right here. I wanted it exact, but I didn't want to print the entire thing to find out that, well, that kind of sucks. It doesn't fit. So there's two ways to do this. The easiest way, in my opinion, is to just use the Control-L, orient this face to the base of the platform. So the easiest thing to do is to adjust the Z offset, and we'll go 50 here. So what that does is, nothing above the bed or below the bed is going to print. So this is just a small section to allow me a quick print that allow me to see if I've got my contouring correctly and make any adjustments I need to the sketch in Fusion 360. The other way you could do this is to use the, I think it's Control H. No, it's Control K. So you can use Control K. You can use this to find exactly where you want to stop printing. And say, I don't know, 4.48 looks good. So with that, you can go into the Process tab and go to Advanced, and you can stop printing at whatever height you want to stop printing. So it will only print up to that point and just stop. So there's two ways. So that saves a lot of time and filament if you're able to do that. If you need to kind of confirm your design before printing out the entire thing.
So here is the completed mount. As you can see, slightly smaller profile, a quick release shoe, and the receiver fits very well. Very good contouring, and that front lip just catches the receiver front. So this isn't going anywhere. It's locked in there quite well. So then it just locks in here, plugs on, and you can see that it's not going anywhere. So what do you guys think? Pretty easy? I consider pretty straightforward. The hardest thing about this project was getting that profile just right so that we could lock that receiver in nice and tight and still maintain that profile. So yeah, one of the tricks that I used to mitigate wasting filament was to take the model into Simplify 3D and drop the entire model except for maybe a ½ inch and print the very top of the model, and that would give me the profile that I needed to know whether or not, of course, it was going to work. And I have 4 or 5 different sample pieces that were more or less failures, But we ended up with a good strong mount that there is simply no way that that receiver is going to fall out. So if you like this video, give it a thumbs up, subscribe if you're not already. If you have any comments or concerns, leave them down below and I'll make sure that I get to them. I read every single one. Okay guys, so until next time, take care.